Hi, this is example number 1 of section 12.6, and we are talking here about parabolic motion. As you know, the only acceleration that we have in parabolic motion is the gravity. The solution of this problem, we have to consider that we have acceleration in x direction is equal 0, and acceleration in y is gravity and is a constant. So when we have constant acceleration, we can integrate that expression to get the velocity, because as you recall, the acceleration is the derivative of the velocity. So if we find the velocity, we can say that the velocity in x will be equals to the initial velocity. So the velocity in the final position will be equals to the velocity in the initial position. And we find that the velocity in y position will be equals to the initial velocity minus the acceleration, which is negative, right? Because the acceleration of the gravity is negative, times time, because I am integrating this expression. And also, I know that the velocity is the derivative of the position. So we know that if we integrate this expression, so we get velocity of in time, and for the y component we get that xy is equals to xy0 plus velocity yt minus gt squared over 2. So usually you learn these expressions by heart. I like to understand them, that they come always from these two expressions that are the ones that we have to learn. Obviously these are vector expressions, and they have two components, in x direction and in y direction, right? So let's see what we got. We got that the velocity in A, which is the initial position, so we can call this 0, which is initial, and this is final. We have the velocity in the initial position and in the two components, since we have the x and the y, because we have the angle, we have the direction. So we have final velocity is equals to 10. And if I project that velocity in the x direction, will be cosine of 30. And then in y, I have the same, the velocity, but now I have to project in the vertical direction, which is sine of 30. The final velocity, when I get over the way here, I have been affected by the gravity. The gravity, what units are we using? We are using international units, and we know that the gravity in international units is 9.81 meters over second square. So here I write 9.81 times. So in these two expressions, what I notice is that I have the time as an unknown. So time is unknown. I need to solve for time to be able to find the final distance, because if I want to use these expressions right here that give me the final distance, this is what I call Sx. I need the time, right? I need this expression right here. So I'm combining x and y, what I'm given. So I know that in the final position, the final displacement is 0. This is 0, and this is 0. And I have the initial velocity, I have the gravity. So in this equation right here, the only unknown that I have is time. Here, this is also 0. So for the x, I can write this will be my initial times cosine of 30 in t, but I don't have the t that I want to find. And s, in this expression right here, I have 0 equals 0 plus the initial velocity, which is 10 sine of 30, you know that is 1/2, minus 9.81 times square. Okay, so from this expression right here, I'm solving for time. And when I solve for time, you see that this is a quadratic expression. The solution will be 0 and t. Why do I have two solutions for this expression? Because it satisfies when I am 0 and when I am already in 1.19 seconds. Okay, having the time, I can go back to my other expressions right now, and I can find the final position with time. Time equals 1.119 I can calculate the final position, which is 10. The cosine of 30, you know that is square root of 3 over 2 times that time that I just calculated. So the position is equals to, I have it right here, 8.83 meters. That's the only question that we were asked to find, which is this final position. We could, if they ask us, we could also find the velocity. How do we find the velocity? Let's find also the velocity. To find the velocity, we find the velocity in x, the final velocity in x, which is 10 square root of 3 over 2, which is 8.66 meters over second, and we find the expression for the velocity in y. We have it right here, so we plug our time in this expression. 10 times 1/2 minus 9.81 times 1.119, and I get this is -5 meters. And the velocity will be, in C, is the square root of the components. So it will be final x squared plus final in y squared. And at the end, if I can calculate that, I get that my velocity is equals to velocity final, which is the velocity in the position C, is equals to 10 meters over second. To solve any problem in parabolic motion, we have to go using those two expressions that are our main expressions. We do it in the x component, this is my y component, and then I have everything in x, everything in y, and then I combine those set of expressions given the information in the specific problem. Okay, this is it for this problem.